So exploring the characteristics, now we did some of this yesterday, right? Now we're just going to take our time, go back through. So we're looking at the characteristics of exponential functions, right? So first off, an exponential function of the form y equals a times b to the x, where a is not 0, right? Because if a were 0, you would just have y equals 0. Where b is greater than 0 and b is not equal to 1. So here's what happens if b is equal to 1. Right? So if b equals 1 and a is 1, you just have a flat line, right? Because it's just y equals 1, right? 1 to the power of anything is 1. It's okay. So we don't want b to be 1. So let's change b. Let's make it 2. 2. Okay. So there's y equals 2 to the power of x. So 1 times 2 to the power of x. Okay, now we could drag this down because we know that it's never going to drop below 0, right? Because we know that if it's 2 to the power, so 2 to the negative 1 is a half, and 2 to the negative 2 is a quarter. Remember, we did this, I kind of went through it pretty quick. 2 to the negative 2 is 1/8, 1/16, 1 over 32. You can see it's getting really close. We can get a small, so as large negative numbers we get, as they get larger, the value of 2 to the negative 10, right, is 1 over 1,024, but it'll never reach 0. So we can kind of drag this down, because we're never going to go below 0. But we are going to climb up fairly quickly too, right? So you can see that even though this goes out to like 8 or 9, we're already off the grid, right? Because 2 cubed is 8. Okay, 2 squared is 4. And I can just drag along here. We can see the values. So as we get up to 3 here, I don't even know if I'm on the... Oh, there we go. So as we get up to 3, you can see it's 8. Yeah, there's 3, 8. Okay, we've got 2, 4 somewhere. Really close. 2, 4, 1, 2. And most importantly, right, 0, 1, right? The y-intercept, which occurs when x is 0, right? When x is 0, you've got 1. So I'm going to play with the a value. Tell me what happens when I play with the a value. So there, a is 4. So what happened? Take a back to 1, right? Or pretty close to 1. So a is 1 here. Okay, let's go to 2. Now a is 2. Now a is 3. All right, it's close to 3. Now a is 3.5. Okay, now a is 3. So what's the a value doing here? What's it changing?
The steepness.
Steepness, and what else? So a is 7. What's going on? It's the y-intercept, right? So the a value is the y-intercept, right? And if you think about it, okay, when a is 1, what have you got? So you're looking at a, so forget the a value. You're looking at b to the x. So 2 to the power 0 is 1, and then you're multiplying by a. Okay. So when you make x 0, you get 2 to the 0 is 1, and then you're multiplying by a. So if a is 7, you've got 7 times 1. If a is 2, you've got 2 times 1, 3, 4. If I just hit play on this, you can see it changing up to 10, and then it's going to head back down again. Now what's going to happen when a goes negative? Well, okay, it's going to reflect over the x-axis, right? You just think about it. So if the a value goes negative, then that value is going down. Okay, so we'll stop that there. Now what happens to b? Let's reset a to 1. 1, 1, 1, 1. There. And what happens when I move the b value? So now we know, right, it's getting steeper, right? We know that because we looked at that the other day. Now the y-intercept is still at 1, right? It doesn't matter whether this is 5 to the power 1. So right now it's 6.1. So when x is 1, it's going to be a little bit over 6. Okay, we can't take a as negative, right? Because what happens when it's negative? Kind of curve disappears, right? So the b value, the base of the exponential, is not allowed to be negative. but it can be between 0 and 1. And notice what's happened here, right? And we saw that. So when b is greater than 1, we have a growth function, right? So as the x values get larger, the y values get larger. We're going to describe an exponential function. It's going to go from quadrant 2 to quadrant 1, and it's going to be increasing, right? So as we move from left to right, we go quadrant 2 to quadrant 1, and we're increasing. If the b value is between, whoops, let's take it to 0.5. No, just take it to 0.5. 0.5. So if the b value is between 0 and 1, then we're going from quadrant 2 to quadrant 1, but what are we doing? We are not increasing. What's a better word than not increasing? We are decreasing, okay? And so it's not growing, it's decaying. So we use the word decay. Okay. So we have quadrant, so when b is between 0 and 1, remember b is not allowed to go negative, right? We saw strange stuff happen when it got, here I'll just hit play and you watch. Okay, so b value is getting bigger, we're getting steeper, now the b value is getting smaller, it's getting less steep. And then between 0 and 1, it did that little flip over to decay, and then it sort of just disappears, right? So what I should do then is set this and say, hey, let's go from 0 to, I don't know, let's say 5. Okay, so it's increasing, now it's decreasing, it's getting smaller, but when it gets below 1, then we go to a decay function, right? Now it's decay. Okay, so increasing, so quadrant 2 to quadrant 1, increasing, that's a growth function, the b value, the base is greater than 1, and as we just fall into here, then we've got decay, right? Quadrant 2 to quadrant 1, decreasing, that's decay. So that's how I want you to describe it, right? Q2 to Q1 increasing. What is that? It's a growth function. The larger the b value gets, the steeper the curve. And here between 0 and 1, and actually I pause that and just set this. Let's say we just go from 0 to 1. Okay, then this will all just be the decay function, right? And as we get closer to 0, it gets steeper on this side, right? It gets steeper. And as we get further from 0, the closer we get to 1, right? Because if it hits 1, you're just going to get a flat line here, right? So that's why it's going down like that. Okay. So this is decay, right? When the b value is between 0 and 1, as x increases, you're getting smaller. Okay. So if you were to describe paying off a loan or something, that's what you want. You want it to get smaller, right? You want the value of the loan to be getting smaller over time as you pay it off. 6-1. Okay, so this just shows a couple of functions, right? Created tables of values. So we know that 10 to the x is going to be steeper, and 2 times 5 to the x, well, what's the characteristic there? It's going to have a y-intercept of 2, not 1, right? So the y-intercept is the a value. Okay, and what do we got here? This is just a couple more functions, just characteristics of them. Okay, which is really what we want. What's 1/2? And then using b values, so these are decay functions. Okay, and wait, I don't think we changed. So let's do this. Let's set this at 1/2, 0.5. So what happens is I change the a value. What do you see? When a is 3, what do you see? A is 4, what do you see? What? Yeah, and a is 7, what can we say about it? You could say, yeah, the y-intercept is 7, right? So what's the y-intercept? A. Doesn't matter if b is between 0 and 1 or b is greater than 1, right? The y-intercept is always the value of a. If A is 1, you just get a y-intercept of 1. Right? And that's what we're interested in, right? Characteristics. What are the characteristics of this function? So somewhere they should actually kind of summarize this for us. Investigate is number of x-intercepts. How many x-intercepts do we have? 0, right? You can't get there. An x-intercept would mean the y value is 0. We can't get there. How many y-intercepts? 1. What is the y-intercept? A. The end behavior, Q2 to Q1, increasing for growth function, which means growth means B is what? Greater than 1. And Q2 to Q1 decreasing when B is between 0 and 1. Domain, x belongs to the reals, and the range, y must be greater than 0. Strictly greater than, right? Not greater than or equal to. We can never be equal to 0. And you've got a horizontal asymptote running at y equals 0, right? An asymptote's a line that a curve will approach but never touch. Reflecting, just asking questions that we've already done. And in summary, the key idea. Look, we're done 6.1 almost, right? Key ideas. Exponential function is a function of the form a times b to the x, where x is the exponent. A cannot be equal to 0, because you just end up with y equals 0. B must be greater than 0, so the base of the exponent has to be positive. B cannot be 1, you get a flat line. All exponential functions have the following characteristics. The number of x-intercepts is 0, the y-intercept is A. The end behavior curve extends from quadrant 2 to quadrant 1, to which I would like you to add the word increasing or decreasing based on the B value. Domain, x belongs to the real, and the range, y is greater than 0. There are two different functions, right? So we've got the increasing or growth function, where b is greater than 1, and we've got the decreasing or decay function, where so that'd be stuff like a half-life, right? You got a radioactive substance that has a half-life of whatever, so many years or something. So each year you end up with half the amount you had before. You'd be looking at a decreasing or decay, right? It's radioactive decay. Further your understanding. So then you got some questions you can do, and you identify which is this an exponential function? Say no, that one's a cubic or whatever. And we've studied polynomial functions already. So as you look through these questions, right, and then right, so that's it, right? So not much further to further there. 6.2. Relating the characteristics of an exponential function to its equation. Very similar, right? So one is, what are the characteristics based on the equation? And this one is, related, given characteristics, then what can you say about the equation? So first one just deals with the number of folds you can make. How many times can you fold a piece of paper in half? Huh? Not 10. Yeah, not 10. Have they gotten to 12? I know you can, if you just took a normal piece of paper, you wouldn't even get to 7 or 8. Yeah. So there's kind of a moment because it just gets too hard to fold, right? You need some large industrial press which you could push down enough, right? And why? Well, because if there's no fold, you have one layer of paper, right? With one fold, you got 2 layers. It's exponential, right? You're getting that increase very fast. At 6 folds, you now have 64 layers of paper. You try and make a 7th fold, you get 128 layers, right? It's like, yeah, I can't do it, not by hand. Determine the values. Okay, and then we're looking at what? Y-intercept, increasing or decreasing. This is looking at the equation now. Give me the characteristics. Okay, 2 times 1/3 to the x. So what do we know about that? It's exponential decay. Going down, the y-intercept is 2. It goes Q2 to Q1. It's decreasing. Okay, and if we wanted to fill in some values, we could. Go to the next page. Still hasn't gone to the next page, has it? Did it? Okay, apply the math. Connecting the characteristics of an increasing exponential function to its equation and graph. Now, special number, there's a special number called E. The symbol E is a constant known as Euler's number, or Euler. It's an irrational number, like pi is irrational, right? Which means it's not rational. You can't express it as a fraction. It's equal to 2.7182818284590. Number occurs naturally in some situation where a quantity increases continuously, such as increasing population. It's kind of the limit of natural growth. Okay? Now, you just may see it as the base. So instead of doing 2 to the x, you're using this e to the x. If you go on into like do any biology or anything like that, you're going to see it as the base of a lot of different growth functions, right? And so you're just being introduced to it here. It rates its own key on the calculator, so it's above the ln. You notice you got a key that says log. Below the key that says log, you got a key that says ln. Above the ln as a second function, you're going to see that little e. Okay, so it ranks highly in there. And just know that it's between 2 and 3, right? It's 2.718. It's growth because the b value is greater than 1. And then it's got the characteristics of a growth function, right? Q2 to Q1 increasing. The y-intercept will be 1. It would be between 2 to the x and 3 to the x because e itself is between 2 and 3, right? So we know where that falls because we looked at that yesterday. 2 times 5 to the x, what are the characteristics of that? You should be able to answer that now, right? You know that the y-intercept is 2 and that its growth goes Q2 to Q1, it's increasing. 9 times 2/3 to the x, is it increasing or decreasing? Which one? Decreasing, right? Because every time you move along, you're getting 2/3 of the previous number, right? What's the 9 do? That's your y-intercept, right? So your y-intercept at 9, and then your next number is going to be 2/3 of 9. And then your next number is going to be 2/3 of that, and then 2/3 of that. So it's decay, right? Because it's less than 1. Right? And that's really what we're interested in this particular section, right? Growth or decay. Shape 8 times 3/4 to the x. You should be able to describe that now. Match the exponential function and its corresponding graph. So you're looking here, right? You're saying, well, this is decay, this is growth. It's got a y-intercept of 3. I'm looking for something with a y-intercept of 3 that's going Q2 to Q1 and is decreasing. So let's haul these up here. So y-intercept of 3. Nope, nope, nope. All right, this one. It's got a y-intercept of 3 and it's decaying. So 1 is C. This has a y-intercept of what? 4. So there's a y-intercept of 4 and there's a y-intercept of 4. Is this B or D? B, because it's a growth function, right? Because it's 3 to the power of x. So it's Q2 to Q1 increasing. What else? This has a y-intercept of 4, so it must be D. And then by process of elimination and the fact that this has a y-intercept of 2 and is a growth function, there we go, right? So we can match up exponential functions with their graphs. Should have written a question like that. Parameter b is greater than blah, 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 right? So characteristics, right? What is the a, what is the b, what are they telling us? I knew the parameter a in a function represents. We know what that does. Okay, so you'll be able to answer any of those questions. And still yet more. Okay, and again, this one is doing what? Which match functions with the graph, you can do that. Key ideas. In a table of value, there's a constant ratio between consecutive y values when the x value increases by the same. Okay, so it means for every 1 increase in x, then you might have a doubling in the y, or a tripling, right? Whatever the base of the exponential, the b value is. If an exponential function is of the form y equals a times b to the x, a is a non-zero multiplier and b is the base. Value of a is the y-intercept. Okay, and again, need to know That's what you need to know, and then there are various questions. Okay, so